The physical space you are sitting in right now feels empty, but it is actually boiling with energy. Our biology restricts our perception to a remarkably small window. We navigate the physical world using only the thin sliver of the electromagnetic spectrum we call visible light. We detect a narrow band of physical pressure through touch and hearing, and we map our environment using highly localized chemical gradients through taste and smell. Even our experience of time is restricted. If an event happens too quickly or unfolds too slowly, it registers as entirely invisible to our sensory system. This cognitive bottleneck is a biological survival strategy. Evolutionary pressures shaped this filter to conserve metabolic energy, shielding the brain from the high cost of processing every environmental fluctuation. These biological filters leave us effectively blind to the continuous, vastly richer physical universe happening around us at every moment. The spatial computing industry currently operates on the premise that augmented reality is an optical engineering challenge, a quest to build better cameras that project visual overlays onto glass. Imagine if hardware successfully sensed every hidden signal in the environment. Looking at the scale of environmental frequencies, the problem becomes clear. First, the system ingests the broader electromagnetic spectrum. RF spectrums, terahertz waves, and thermal fields flood the sensors. Then comes the microphysical layer: neutrino flux, invisible molecular gradients, and localized magnetic anomalies. Finally, the biological data streams in: bioelectric emissions from nearby humans, structural microvibrations in the surrounding architecture, and rapid shifts in atmospheric chemistry. Mapping this raw data directly to the human visual cortex results in signal chaos. The human brain, entirely overwhelmed by the noise, collapses. The sheer volume of sensory input renders the user catatonic. Building the hardware to detect these signals is a solved problem. The actual constraint lies in the limited volume of data the biological brain can ingest before failing. To bridge this gap, we require a universal sensory compiler. This system functions as an AI-driven perceptual abstraction layer designed to translate the complexity of reality into a form the human mind can actually use. Augmented perception is less an optical problem and more a challenge of cognitive bandwidth management. The blueprint for this compiler is the Cognitive Augmented Reality Interface, or CARI. It relies on a three-tiered architectural stack to process environmental data. At the base is Layer 1, the omnispectral sensor mesh. This operates as the ultimate environmental data vacuum. The mesh continuously samples the electromagnetic spectrum, absorbing terahertz waves, microwave reflections, and UV polarization. Simultaneously, it pulls in acoustic and chemical inputs, tracking infrasound topology, hormonal traces, and localized pollution signatures. It maps biological and quantum scale states, reading everything from microbiome clouds to coherence anomalies. At this layer, the physical environment becomes a continuously queryable, infinite data stream. The raw feed passes to Layer 2, which strictly avoids the rendering of images. Instead, it builds a latent multidimensional world model, a continuously updating, hidden state simulation of reality. Much like a large language model infers context from individual words, Layer 2 analyzes sensory tokens to model the underlying environment. The AI examines the data to identify hidden structures and map causal relationships between variables that humans cannot naturally perceive. By tracking these relationships, the model calculates immediate environmental dangers and the complex biological states of those around the user. Layer 2 organizes impossible physical complexity into a structured, semantic model of reality. This model is passed to Layer 3, which is governed by a single rule: the user must never be exposed to raw data. This is the cognitive compression layer. It acts as an adaptive translator, determining the minimum perceptual representation required for human understanding. Consider a scenario where the sensor mesh detects a combination of jagged RF anomalies, thermal spikes, and shifting sonar blobs behind a barrier. Layer 3 translates this complexity into a clean semantic output: two stressed humans behind this wall. Similarly, the detection of specific microvibrations and electromagnetic leakage is compressed into a direct warning: electrical instability likely within 30 seconds. The AI condenses billions of physical data points into intuitive symbols, spatial meaning, and emotional salience. Layer 3 acts as a protective cognitive membrane, keeping the user focused while granting them the full benefit of omnispectral awareness. A human equipped with this architecture navigates obscured, complex environments with absolute spatial confidence, without needing traditional visual sight. This creates synthetic intuition. The user experiences a sudden sense of spatial certainty and threat awareness without having to look at data matrices. The AI also functions as a temporal compressor, expanding human perception across different scales of time. By accelerating slow processes within the world model, a user can intuitively sense structural fatigue in a building or the gradual progression of a disease. The system monitors causal tension across entire environments, detecting subtle shifts like collective biological stress in a crowd or microfractures in infrastructure before a physical failure occurs. Humans using this architecture are no longer trapped in the present moment. Their perception natively spans the causality of the past and the probability of the future. Over time, the system forms a closed learning loop, continuously studying the specific neurological quirks of its host. This develops into a personalized perceptual ontology. The brain structurally adapts to the device's semantic outputs, and the software adapts to the user's cognition. Eventually, perceiving invisible data becomes subconscious. Learning to feel magnetic tension or Wi-Fi reflections becomes as natural as the sense of touch. The overwhelming, chaotic noise of the surrounding physical universe ultimately resolves into a perfectly unified state of total comprehension. Humanity shifts from a primitive reliance on bouncing photons to directly perceiving the underlying fields, intentions, and dynamic systems that govern reality. The ultimate spatial computing interface acts as a cognitive extension, physically disappearing as it unlocks the deepest layers of existence.